Okay, hello. In this video, we're going to be covering pointers in C++. So I'm only going to be covering. I'm not going to be covering dynamic memory allocation yet. We'll do that in another video. So I'm only looking at in this video how you declare pointer variables, and then how you use them. So how you dereference them and how you point them to things in memory. And then I'm actually going to look at where variables are actually useful. So when you combine them with classes and structs, you can use them to create more complex data structures. Okay. So before I jump to the code here, pointers, I know, is often a complex topic, is a tough topic for many students. So, I mean, the first thing to remember about pointers is that a pointer is just something that holds a memory address, okay? So that's the way I think of a pointer. What goes into a pointer is a memory address. Now that memory address references something. It references some data of a particular type. But then when you have that memory address, it's pointing to, it's referencing some memory. So then you can use the address, you can dereference the address, as we call it, to go to that memory and do something with it, to read it out or to actually change it, okay? So that's what a pointer is. So let's look at declaring a pointer in C. Let me build this, make sure it's building still, and run it here to this first breakpoint. So at its simplest, the syntax for creating a pointer variable is like this. So you notice we have the star. So in addition to meaning multiplication in C, the star is used for defining pointers here, okay? So when you see this, I mean, this P is not a regular integer. P is a pointer. P holds a memory, an address in memory, or it will hold an address in memory once we initialize it, okay? Now, I mean, pointer, yeah, so, you know, we don't use a pointer keyword or anything. We simply use the star to change it from a regular variable into a pointer variable. So you can have pointer variables of any type. So we could create something that points to a character. A quick style note: this might not be doing what you think it does. This is why it can be a bit dangerous to have the star next. I prefer having the star indicating a pointer next to the type. But if you do that the way I prefer, and if you try to define multiple variables on the same line, multiple pointer variables on the same line, it won't actually. So X will be a pointer variable, but Y will just be a regular integer, which is problematic. So the textbook, and you'll see a lot of people use this style where you put the star next to the left of each variable. I prefer, because whenever I see this, I read this as a character pointer. So instead of a regular character, this is a character pointer, a car pointer, or this is an integer pointer. So I kind of like to have the star next to the type name. So, and again, since this is my class, I'll probably be asking you to use my style for programs you do for my class. So I instead I prefer to have all pointer variables on their own line when you're declaring them. So I have an integer pointer X and an integer pointer Y, right? So this will work the way that we expect, okay? In general, for the style for this class, all variables should be defined on their own line instead of having multiple definitions, usually. So anyway, so that was a couple of different pointer variables. I mean, you know, any type. You can have any type. So I could have a pointer to a float or a double, so on. Okay. But yeah, let me go ahead and step over all those definitions. Let's go down to looking at using a pointer variable. So there's another example. So we're going to create an integer called myInt. And we create another pointer called ptrint, pointer to int, okay? Here's another style thing, so I might not have this in my class style guidelines, but most places they're doing C or C++ programming, if they're using pointers a lot, they'll specify that all pointer variables have to start or end with some particular suffix or prefix, okay? So I prefer to use a prefix of ptr. So all pointer variables I usually create are ptr something. So in this case, pointer to int. And here's our first example then of something besides declaring a pointer variable. We're going to point pointer int to my int. So the ampersand is referred to as the addressing or the address of operator. So when you do ampersand something, it gives you the address of. So like I said, pointers hold addresses. The ampersand finds the address. So whatever the address of my integer is in memory, it'll find that address and it will put that address into the pointer int. Okay, so let me visualize that. I had a little figure just for that. So if we have my int defined and a pointer, an integer pointer type that we point to my int, it looks something like this. My int is an integer, so it actually, integers take 32 bits or 4 bytes of memory. So if you look, if you went out and looked in your computer memory, you would find like my int might have been assigned memory, say starting at hexadecimal address 2000 in your computer, okay? And since integers need 4 bytes, every memory address typically in your computer memory holds 8 bits or 1 byte of information. So if my int was assigned memory starting at 2000 in computer memory, it would actually be using the addresses 2000, 2001, 2002, 2003. And I meant to show this being initialized. If you initialize my int to 1, since if this was like an Intel, it depends on your CPU, your processor. If this was an Intel that uses little endian, the least significant bits would come at the lowest memory address. So if we assign 1 to my int, you would get 1 here at address 2000 and then zeros at the others. Okay. So then back to pointers. So if we assigned the address of my int to pointer int, memory address 2000 would just get saved into whatever wherever pointer int is in memory. Okay. So you get 2000. So basically, that's the way a pointer works. It's a memory address, and then if we dereference this memory address 2000, we go back to what it's pointing to, this value in memory here. Okay, so let's show that. Although let me stop because I want to initialize that to 1. I'm going to show you something real quickly on the debugger here. We'll stop the debugger, set a breakpoint right there, rebuild. Actually, I'm going to breakpoint right here. And let's run it back to that point again. Okay, continue on. There we are. So we've declared our 2 variables, my int and pointer int. We're about to sign. I need to do one more thing. Sorry. So I wanted to also output the memory address. Like that. And I'll also just show. In fact, if we print out the value that's in pointer int, we will see that it is, in fact, a memory address. So notice I'm not dereferencing them. I'm skipping ahead here. I didn't talk about dereferencing. Well, I did. So we're doing the same thing here. So when you use the I'm sorry, we're not dereferencing. We're getting the address of. So when we get the address of, I use it here when I was initializing pointer int. But you can use this ampersand, the address of, in expressions and other places. So I just did it again here. I got the address of my int and we'll print it out. Okay. Okay. So now I think I'm ready. So to illustrate what I wanted to. So let's rebuild that and run it down to that point. Continue on from the top here. So now we're here. So now we look at the output here of these three statements that we just executed. Okay, so my int does have a value of 1, so we see that's the actual integer value that's in my int. Now, if you look at the ampersand from the first line here, you get this actually a hexadecimal address here, 0055. This is the memory address. So instead of memory address, hexadecimal address 2000, my int was actually allocated memory, 4 bytes of memory starting at 0055 FB38. And indeed, if you don't dereference pointer int, if you just look at what is actually in pointer int, it is that memory address, 55 BF8. Okay, and then real quickly, let me copy that. So in Visual Studio, you can actually look at get raw memory. So you can look down at the bits and bytes in raw memory. So I could actually paste in that memory address. I don't know if you have to put the 0x in front or not, but look at it here. So there again, so instead of laid out in a column, it's laid out in rows. But look at these 4 bytes right at memory address 55FB38. 1000, like I showed on the slide, because we assigned 1 in there. This is a little inane machine, so the next 4 bytes, the least significant 2 bytes or least significant byte of my 4 bytes representing this integer ended up at that address, and then we had the next 4 there. All right. So yeah, I mean, I don't normally look at memory, raw memory like that, but yeah, it's a tool that you can do there. So continuing on then, so that's the basics. So we've defined a pointer variable called pointer int, and we pointed it to my int. Okay, so let's see how you can use that. So here we'll define another integer called another int. Oh, I didn't mean to hit restart there. So let's get there. I meant to step. I'll step over. Yeah, so this was actually, this line here that I just executed was our first example of dereferencing a variable. Okay, so you use the star to declare a variable of type pointer, but you also use it to dereference. Okay, so if you've got something that holds a memory address, if you put a star in front of it, so if you've got something that's a pointer, putting a star in front of it doesn't give you the memory address, it dereferences it. So it follows where that's pointing to memory and accesses the actual value. So in this case, we access it's pointing to my int, which has the value 1. So we would pull 1 out of memory and we would display it on cout, like here, like you see. Okay, so those are the 2 fundamental operations. So creating a pointer variable and then using address of to make a memory reference or to find a memory address, and then using star to dereference a memory address. Okay. So some other things you can do with pointer variables. So if I create another integer, I can create I can point pointers to other things. So here we're gonna point it to this new integer, another int. Oh shoot, sorry, I keep hitting the wrong thing there. I keep hitting restart. Not what I want to do. So I should be using my keyboard shortcuts here. Let me restart again. So let me use F10, step over here. So if we create another int, and we assign 42 to it, and we point pointer int to that. Now if we dereference pointer int, remember, I mean, my int has 1, another int has 42, so if we dereference pointer int now, it should be pointing to this 42 value. So we should see 42 come out here on our cout, on our terminal output. Okay, now you can use the dereference, the star, for more than just reading values. You can actually also use it to write values. Okay, so if you use star pointer int, so dereference my pointer int, but use it on the left-hand side of an assignment, I can assign a new value to whatever pointer int is pointing to. So here we're going to stick negative 42 into another int, since pointer int is currently pointing to another int. So negative 42 will go into another int. So, and again, this is just proving, So after we did that, I mean, my int still has the value 1 because pointer int isn't pointing to it. Another int has the value negative 42 because another int is what pointer int is pointing to. Okay, so negative 42 is another int, or if you dereference pointer int, they're both pointing to that same value, negative 42. All right. So that's the basics of pointers. So you can have two pointers pointing to the same thing. So if I create another pointer called pointer also int, and if I point it to the same thing, so here I didn't use the address of, I just simply assign whatever the address is that pointer int has, I assign that address to pointer also int. So now both of these are pointing to the same thing. And now, so if I assign a value, both pointer int and pointer also int, they're pointing to another int. So all three of those things should have the value the value 9999 in them now, if we look at them. So they all have 9999. All right. And I already covered these. I should have moved this code up to where I did this. So talking about the address of and actually looking at memory where my int is. So one final thing. So if you ever want to know what the size is of a particular data type in C or C++, you can use the size of function. So indeed, for example, if we look at the size of an integer, my int is an integer value, it comes out as being 4. So that means that it takes 4 bytes, or since a byte is 8 bits, 32 bits. Each integer uses 32 bits of memory, or 4 bytes of memory. So, all right. Now, I mean, everything I just did here using pointers to integers was really just for illustration purposes. I mean, you almost never do things like that, setting up a pointer to a simple data type in C, like a character or or an integer or something like that. So, I mean, where pointers are really useful is when you start pointing them to classes and structures. So you can use this to build more complex data types in C and C++. So let's look at an example of it. So if I have a structure, I can create a pointer to a user-defined data type like a structure or a class, just like we can create a pointer to a simple type like an integer or character. So in this example file, I've got a structure called student type defined up at the top. It's a simple record. So student type is a user-defined structure, user-defined type that has 4 member fields: name, campus-wide ID, GPA, and grade, all of different types. I'll come back to this later. So if we create a variable of type student type, and then we can create a pointer to student type variable. So here this is saying that I'm creating not a simple variable of type student type, but a pointer to a student type variable. And at the same time, when I create the pointer, I point it to this variable that we just created, student variable. Okay, so pointer student is pointing to student. So as you remember from a previous lecture, for structure, the student structure, if I want to access a member of the structure, like the name field, the name member, I can use the dot to access it. So name was a string, so I could assign like a string to it. Now I could use my pointer in the same way. So if I dereference the pointer and use the dot, I could assign a value to that. So notice we have to use parentheses around here because the dot operator has higher precedence than the dereference operator. The textbook explains this as well. So if you didn't have the parentheses, I won't type that in there, but if you didn't have the parentheses, it would try to first find a member in pointer student, which is a pointer variable. It's not a student type variable, so it wouldn't work. So you do have to have parentheses if you do it like this. Okay. So that should have had the effect of assigning this value to the campus-wide ID. Now, dereferencing a pointer to some kind of a structure or a class and then accessing a member field is so common that a special operator is defined in C and C++ for doing both of those at the same time. That's what this little arrow, a dash right arrow, is in C++. Okay, so this does exactly the same thing that I did in the previous step. So this does both the dereference, so it finds out what pointer student is pointing to, and then it accesses the GPA member field. In this case, we access that member field to assign it a value, 3.8. Likewise, so again, a second example of this. We dereference what pointer student is pointing to, access the grade field, and assign it a character grade of A here. And then we can, we've got a little helper function. Again, if you look at the top right under that, this helper function takes a reference to a student as input, and well, we're just printing out the fields of that. Actually, we're creating a string of the fields and printing those out there. So if we go back here, we should see that it outputs. The point of this was to show that all of these assignments work, whether we did it using the original structure for the name, or whether we used our pointer to the structure, dereferencing it like this, or used this arrow operator to simultaneously dereference and access the two fields. So we assign all four of our field values in the same location in memory. So all of these are referencing the same location, the same memory that was allocated when we created the student variable of type student type. Okay. So it is equivalent. So I could have also called toString by passing it the dereferenced value of pointer student. Okay, so this does the same thing here. So I should get the same output. Okay. So, all right, the arrow operator works also on classes as well as structs. So remember that structs and classes are essentially the same thing in C++. The only difference is the default, whether things are private or public, for member items that you add to the class or the struct. Okay, so but typically for a class, member variables are defined as private, so you can't directly access member variables. But what are usually public for classes are functions, so member functions of classes. Okay, so in this example code, I gave another version of student type, and in this case, a class. Let me go up and look at the class version of the student type. So if you look in there, there's another. I had to give it a slightly different name, so I call it student type class instead of student type. Maybe I should have called the first one student type struct, just to be clear. But in the class version of this record, we've got the same four fields, but we declared these private. Okay, so even if I wanted to, if I tried to access these member fields, you would get an error message that they're private. But we defined a couple of functions in order, as getter and setter functions, so we could set. I only defined setter and getter functions to set the name here, just to illustrate. Although there's a constructor. So there's a constructor where you can pass in all four of the parameters and it'll initialize all of them. And then there's a setter and a getter for the name function. And then there's also a version of toString for the class to convert the instance of the class to a string here. So if we create one of these student type classes using our constructor where we initialize all the values to these to these values, Joe Mo, and then the campus-wide ID, and then the GPA, and then the letter grade. Now, so again, we can create a pointer to a student class type. I I didn't use my style there. So we can create a pointer to another student here, like this, address of another student. And then this is to illustrate then that now that we have this pointer set up, we can access member functions like we were accessing member variables for the structure here. So I probably should have given an example of, let me stop that and restart. So for example, so remember that these, not get name, the name is a private member variable. Now if it wasn't private, if it was public, even though it was a class, I could do this fine, that would be legal. But if you try and reference that in order to like assign a variable directly for a private member variable, you'll get an error. Should be a compile error. So yeah, the Visual Studio will recognize that, and you'll get an error when you try and compile. So you can't do that. But if you have member functions that are public, we can call those using the same arrow. So dereference and then access. So here we're dereferencing and accessing a member function in order to call it. So I'll rebuild after I comment that out, and we'll rerun. So we come down and hit our breakpoint. That wasn't our breakpoint. The next one, there it is. And let's step over. So there, I called set name using my pointer, and we changed the name to Joe Schmo. I had the name wrong when I created the variable, so we wanted that. So another example of accessing a member function through a pointer. So we can call the getName accessor to actually get the name, so we in fact see that in fact the name was changed by calling the setter to Joe Schmo. We can also access any public member function like toString to get the string, to get our whole thing. So this just shows that the constructor was working. So we only changed the name, but the other values came from providing those in the constructor to the class here. Okay, so one other thing before I leave this class here, if you had a good eye, if you were quick when I brought it up here. So remember in the previous video when I talked about classes, I mentioned that when you have a member function, let's start with the set name member function. It's as if there's a implied reference to the object being passed in. So, and in fact, that's what happens. So what's actually being passed into member functions is a pointer variable. And the pointer variable has the variable name this, okay? So if you see code like this, and I used it on purpose in this example so you could see, so this is a pointer to the particular student type class that we called the member function on. So I can use this pointing to name, just like we did just a moment ago down in the main function, to assign the value. So here, name references, I use the same variable name, NAME, both for the parameter and also for the member variable. Okay, so this helps disambiguate here. So the name of the parameter is NAME, and then the name of our member variable, we can access our member variable by using this, which points to name. And so assign the parameter into our private member variable. And again, since this function is part of the student type class, it's legal to access private member variables like this, right? So we can do the assignment of the parameter into the variable, okay? I use that same thing for the constructor as well. So we passed in the parameters with the same names as the private member variables, and then we caused the private member variables to be assigned by using this, which points to name and CWID and so on. And same for the getter function and to get the values for the toString function. Okay, so that's what this parameter is in classes in C++. All right. Okay, one final quick thing. I'm probably gone a little bit longer than I wanted to on this video, so let me show you a quick example of what we're going to be, another thing we're going to be using pointers for in this class to create things like linked lists or more complex data structures. So another thing that if you had a quick eye you might have noticed, back to my structure at the top here, my structure had 4 fields, but I had a 5th field called next, and the next field is a self-referential. It's a pointer variable, but it's a pointer to a student type. Okay, so again, remember this next holds a memory address, and I can use this to have it hold to create a linked list basically. So how do we do that? Let's show it here real quickly. So I already have a student created of student type. So let's create a second student called student 2 and give him this name and campus-wide ID, and a third student called student 3 and give him this name and this campus ID. Now we'll use this next member variable to create a linked list. So my first student that I created up at the top of main here, I will assign the next memory address, the next pointer variable, to be the address of student 2. So we just pointed student 2's next field to be pointing to student 2. Likewise, student 2 next field will point to student 3. And this is common for the end of a linked list. So we need to indicate that we're at the end of our list somehow. So we will use a value known as the null value. Your textbook talks a little bit about what this is. But we'll indicate that there's no student 3 there's no student after student 3 by assigning the next pointer to null here. And then real quickly, here's an example of stepping through. Let me get down to this point here. We'll step through these. So here's an example of actually stepping through my linked list. So I'm going to start at the beginning of I'll create a new pointer variable called pointer to student. Where did we create that? Well, somewhere at the top we created the pointer to student is just a pointer to a student type, but we'll repoint it back to the first student in our linked list. Okay, so the first time through this while loop, pointer student is pointing to the first student number 1. Okay, so if we output the first student, I'll just go ahead and step through these here. So the first time through this loop, student number is 1 here. When we call toString on dereferencing pointer student, we get our first student, Jane Programmer. Okay. Now here then we follow the next pointer so that we can follow it to our next student. So by doing this right here, our first student was pointing to the second student. So we get the address of the second student, and that becomes what pointer student is pointing to. Is pointing to the second student. Okay, and then we increment our student number. So the second time through the while loop, student number is 2, and pointer to student is pointing to student 2, the second student here that we gave a name of John Jingleheimer. So when we print it out, we see our second student. And then the third time through the loop, we've pointed it to the third student. So we end up outputting our third student here. Now at this point, we're going to end up assigning null. So the third student, its next pointer has a null value. So null will get assigned into pointer student. So if we look at pointer student, see it has null or 0 there when we did this assignment. So that will end the while loop. So this is typical for a linked list like this. So we're done with the loop. And we printed out all 3 students that we had on this linked list that we created by hand here. Okay, so like I said, I probably went a little bit longer than I wanted to in that video. That's the basics of pointers. I mean, pointers are a little tough to get your head wrapped around. Make certain that you keep in mind a pointer holds a memory address, okay? So if you get that, you know, if you can get that into your head about what it's doing, that it holds an address, I think hopefully, I mean, it makes it easier to understand eventually. So work with them, and that's it for this video, and I will see you on our next video then.